the mineral name of which is olivine. So here you have olivine and metal mixed together. Just like a raft sinks down into water, that layer of olivine in the mantle presses its way down into the core, and where they mix, you get probably our prettiest meteorites. You want to make sure you hold this one kind of underneath it, because the edges are a little bit delicate, but you can pass that around and take a look at it. Okay, you ready to move on? Okay, so how many of you have been to Hawaii? You have? Yeah? In your next field trip to Hawaii? That's what I heard. Next year? You're going to Hawaii? Okay. So what kind of rocks do you find in Hawaii?
Lava.
Basalts, right? Okay, basalts. So do you think they're basalts on asteroids? Yes, no, no. Well, if you melt something, do you get a basalt? Okay, so there are basalts on asteroids. So this is one. This is Ibatira. It's a relatively rare vesicular basalt. So just like, gases in magmas on Earth are trapped to make vesicles, you see that same behavior in a few meteorites. It's actually pretty rare. But this one is really cool. So this, except being, like modern day lava flows in Hawaii, this is 4.5 billion years old. So here's your concept. You ready? You went from these little grains floating in the solar nebula all the way through a rock like this that accreted, to heat it up, melt it, differentiate, make a core, a mantle, and a crust, cool it all off, and you did that all in 50 million years. That's how fast things happened in the early history of the solar system. And then for the next 4 billion years, the major process was what we see in here, which is impact, basically bombarding objects, breaking them down into smaller and smaller pieces. So, who's the most senior? Are you guys all the same level, or?
He's graduated.
You've
December.
You graduated?
She also did.
Okay, so you've had mineralogy, right?
Yeah. Not for me. Not for me.
No. So you ready for your mineralogy quiz?
I'm bringing it.
You're bringing it? Okay, here we'll give you a mineralogy quiz. I think you can handle it. What do you think?
Yes, I got this.
You got this? Okay, who's doing this?
Probably not me. That's obnoxious.
Okay.
One of the students.
Okay, we're gonna get a student over here to
Ben
do
can
this.
do it.
I could probably do it.
Oh, who's willing to do it?
Ben is.
I would, but I'm making a video right now too.
Okay, so all you gotta do is step over here.
Convenient.
Okay, who's gonna step up?
Ben Miller.
Okay, so
Where's that?
in this pocket, take a look. In this little vesicle is a green mineral. All you have to do is tell me what the green mineral is, and Allie will give you an A for whatever class you take next
For
semester.
this class.
Or for this class.
Yeah, one
Oh, okay, yeah.
I graduated.
You graduated too?
Yeah, but you can still fail this class, buddy.
Yeah.
So it's a green mineral, so have we seen any green minerals on the table?
Yep.
Which one?
All of it.
Olivine. Okay, so do you think it's olivine?
I don't.
Oh, see, okay, we're on the right track. So we think it's not olivine.
Zircon?
Anyone else want to take a look?
Sure.
We can get a second opinion in here.
Okay, but
We'll give Allie the test.
Oh,
Let's see if
Lord.
Allie can get it. What do you think, Allie? You recognize that mineral?
Oh my gosh. I need a little focusing. How do I focus?
This? I just tightened it so it's falling.
Ooh.
So describe it to your students.
Kind of a glassy
Hair
luster.
Professor Dr. Gale.
Glassy luster. Ooh.
Is it dark green or light green?
Pale green.
Pale
very,
green.
Very delicate.
Pale green.
Very
Okay.
delicate.
So,
I think
what do you think?
it could be olivine.
Okay, she thinks it could be olivine. That's an excellent guess. It's wrong, but it's an excellent guess. Okay, what if I told you that this is the most common mineral inside of you?
Apatite.
Apatite, that's right. This is calcium phosphate, except this calcium phosphate is 4.5 billion years old. Okay, formed at the birth of the solar system there. That's pretty cool.
Calcium phosphate.
Calcium phosphate, formed actually during metamorphism of this rock. Okay, so here's the cool concept. Let's go back to this rock. Everything you know, everything you've come into contact with, everything you eat, drink, sleep on, ride in, gasoline, every single thing you know, every atom of every one of those things came out of a rock like this. And it was 4.5 billion years of natural and man-made processing that produced every single thing you know. So if you took the entire Earth, you put it all back in a blender, and you blend it up into some analogous goo, the composition of that goo would be the same as this rock. How's that for a concept?
I find it mine.
Okay, so now we're gonna go back to the quiz.
That means we all have stars inside.
Because you guys are all doing great here, okay? So we're just gonna call on people, okay? Remember, this is easy. Just call them out when you know them, okay?
Let me tell you that I didn't sleep very well last night.
Yeah. Okay, you.
Okay.
What color are you going to describe this as? This outer surface here?
Dark gray.
Dark gray, okay. Sure, okay. Dark gray or black? Sure. Okay, we'll go with that. And what... okay, and you, what are we going to describe as the finish of it? Is it shiny? Is it dull, matte, lustrous?
I kind of say kind of
Dull, okay. Dull. Okay, see, these are easy. We're just calling them out when we know. Now, let's go to this rock. Okay. So, what color are we going to describe that as?
Black.
Black. See, it's so easy. Okay, and how are we going to describe the finish of that? Just shiny. See, these are so easy. Okay, so these things, which are primitive, have dull fusion crusts, and these have shiny fusion crusts because these melt at a lower temperature. Basalts do. So when they come into the atmosphere, they melt, and you can see that that's a shiny fusion crust. Okay, so now I need a volunteer. Who wants to step up? Be a volunteer. Okay, so put your camera down.
So that's interesting.
Okay, put your two hands out like this, flat on the table, and you can cup them a little bit, and leave them together. And don't move them. I'm sorry. Leave them there. Don't move them. Got it? Okay. You think you can handle this assignment? Okay, good. I hope so. Because otherwise your hands go on the pike and it would be really unpleasant for you. Okay, we're going to put one rock there, and we're going to put one rock here. Got that? Anyone take this picture? You'll want this picture later.
Yeah.
Ben, take one, Mikey.
Make sure you get his face, not just his hands.
Yeah, he's got to show his mom. She won't believe it.
Yeah. Okay, everyone got that? Okay, so what do you think you're holding?
Rock.
Meteorite. All right. There you go. Good answer. Okay, well let's start with this one. Okay. So these are both meteorites, so they're rocks from outer space. Okay. So this is a breccia again. No, I didn't say move your hand. So this is a breccia, rock composed of bits of other rocks. So what color are we going to describe those little bits as?
Gray.
Gray or white. Pretty easy. Okay. But we've established this is a meteorite, so it comes from where?
Space.
Space. So where do we see a lot of white rock in outer space? The moon. So that's a piece of the moon. So you're holding a piece of a north acidic regolith breccia. So this is the dirt basically from the white parts of the man and the moon. Okay, so if this one is from the moon,
Oh man.
where do you think that one's from?
Mars.
That's from Mars. You're holding a piece of Mars there. Now, you're a good scientist, right? Yeah, okay. So the question you're going to ask me about that one is what? How do I know it's from Mars?
How do I know it's from
See,
Mars?
there you go. Okay. Okay. It's like ventriloquism. How do I know it's from Mars? Okay. So how do I know it's from Mars? Because how do I know this one's from the moon?
Composition.
Okay, but what do I have to compare it to?
The Earth.
No.
Rocks that buzz Aldrin crap.
Yeah. I mean, we have like
Yeah.
hundreds of pounds of rocks from the moon. So telling something is a moon rock isn't all that challenging, right? We know a lot about the moon. But have we ever brought a rock back from Mars?
No.
No. So how do I know that's from Mars? If we've never brought a rock back, how can I be so sure?
Geochemistry to the rescue.
It's a rock like this. So this is Zagami. It fell in Nigeria in 1962, and it's been kind of cut into this odd shape. But see that little black pocket? This is the fusion crust. That's the part that melted when it came through the atmosphere. But this little black pocket is not fusion crust. This rock was sitting wherever it was. It was having a day. It's a rock. We don't know if it has a good day or a bad day. It's just having a day. Okay? Something smashed into the surface and sent a shock wave through this. And when it reached that little point, it melted it. So that's a shock melt pocket. And that shock melt pocket, if we extract the nitrogen and the noble gases, now this is where you get to name the noble gases in order.
I'm ready.
Who's ready?
Hit me.
Helium.
Helium!
Argon.
You only skipped one.
Neon.
Neon.
Neon,
Krypton.
argon,
Radon?
krypton, xenon.
Xenon.
There you go. Okay. So if I measure the nitrogen and the noble gas in there, they're almost a dead match for those measured in the Martian atmosphere by the Viking lander in 1976. So even though we've never brought a sample back, we've measured the composition on Mars, and that's how we know we have Martian rock. So I could take this one and put that one in its place, and there you're holding another Martian rock. Okay. Now, anyone else want to hold these? Here,
Guys, you have the
I'll
chance to
pass
hold
them.
Mars.
Yeah.
Sweet.
Look live.
Okay, come around here. I'll do the. Why don't you guys line up here,
For the portrait
and we'll
session?
do it that way. Yeah, I'd rather do it that way than take the chance
Hey,
of
can
passing
you-
them around.
Can you hold that quick?
Hold it real quick. It's humbling.
Can you open this up for just a second first, and I'll.
This bag?
Here you go. You can,
Mars.
and the moon.
Moon.
Just drop that.
Oh, it's actually recording?
Yeah.
Okay.
Oh, this is.
Mars, moon.
Knock what?
Which one is which?
Mars, moon.
Alright.
I
There
don't want
you
to take
go.
my hands off the table.
So it was
All
observed.
right.
It was observed
Thank you, sir.
falling.
Yeah. Nakla fell in Egypt. Come on. Nakla fell in Egypt in 1911, and it
Thank you.
supposedly struck and killed a dog. But if you read the original reports, it actually says the dog was struck and turned to ashes in an instant. So not exactly the most believable report. So
Turn to ash.
Yeah.
Poor
To
spot.
dust we shall return.
yeah, it was a. What do you think?
Very cool.
I didn't think of
I
it.
told y'all you were gonna get to hold Mars. How many people in the world get to hold Mars then?
All the Martians.
Yeah.
Yeah,
How many are there?
not too many.
Yeah, all named
All
Martian.
right. There you go. What do you think?
Pretty cool.
Don't get to do that just every day.
And what is anorthosite, pray tell?
An orthosite?
Young geologists.
Peer punch
What is
quiz.
the key word in anorthosite?
Nope, that's it.
It might be anar.
Nope, don't drop that one. You can't afford it.
Anorthosite, which is a type of what mineral? Anorthite is what?
A
Ooh, I'm gonna be
feldspar,
calling some Bill Cordua on
right?
y'all.
Is it a
It's
feldspar?
a plagioclase feldspar. You got
No,
it.
she's not vinegar.
Oh, yeah. I'm too busy scolding. 1, 2,
Yeah, I got it. Come on.
3. Let me take one more just in case.
Okay, and here's your little factoid. This rock, gram for gram, is worth more than cocaine.
1, 2.
So,
Nice.
Oops. Sorry. I'm failing you, Anton. Sorry.
And after,
Oh, this is killer.
after I did all your grading for you
I
too.
know.
alright.
No
Do
excuse.
the last one or the more? Have you guys gotten to hold it yet?
No.
Here, hold them over the table. There you go.
It's wrong.
Yep.
Not seeing it.
No.
Not seeing it.
Just push the button. Yeah.
Got it. It's wrong. There you go.
Now, Tim, I'm remembering Mars in 06 having more fusion crusts. Has it been?
We have
cut
a
up
different
or not?
stone, but I'm
Oh,
not
got
sure
it.
where we put it.
Okay,
Uh-oh.
that's a bitch.
Yeah, this is bad. This happens all the time. It's like, where did we put our Mars rock? I can't remember.
I'm just remembering because I have a picture of my sister looking like she was holding a dog turd or something. Yes.
There you go.
Jen, you're holding Mars. Figure it out.
Okay, so,
Can I just hold it real quick?
sure. Here, you
I
can just
find
hold
it
them for a
humbling.
minute. Okay, so we have something like 100 Mars samples, but one of them is not like the others, and that's this one. Do you know how I know this is a special rock?
Fusion crust.
It comes in its own little flying saucer, that's right. So, but this one, you can kind of make out the fusion crust if you hold it like that and see the back. But this rock is probably the most important rock in the solar system. You know why? Because this rock from Mars is at least 4 billion years old. And that means it survived the warm, wet period on Mars, when all the channels were formed and water flowed across the surface of Mars. And in 1996, scientists from Johnson Space Center argued that this rock contained evidence of past life on Mars. Now, this rock itself was found in 1984 in the Allen Hills region of Antarctica. The Smithsonian, along with NASA and the National Science Foundation, sponsor the U.S. Antarctic program. And we've collected more than 20,000 meteorites from Antarctica over the last 30 years. But this rock, that program runs on maybe $2 million a year. But because of this rock, we've now launched a whole flotilla of spacecraft, including the Spirit and Opportunity rovers, the Curiosity rover, all to look for, not for life per se, but for environments that are habitable for life. And so most people that have heard of any rock at all, have heard of any meteorite at all, have heard of this one. You guys can pass this around. ALH 84001 is found in the Allen Hills region of Antarctica in 1984, and it was the first one that was cataloged when it came back from Antarctica.
Ooh, there's an interesting texture in this.
Yes, there is. I wrote a whole paper about it.
Really?
Yeah.
It's like not spinifex, but it kind of looks.
So the cool thing about this rock is that if you hold it like that, okay, we have a couple of rocks that are this way. If you hold this rock just like that, you can see how this layer is more uniform than that layer.
Yeah.
This is a cumulate pile, so you can actually orient this rock the way it was on Mars when it formed by looking at the crystallization in there. We have a couple of others where the metal and sulfide within some impact melts are oriented. They look like little acorns in CAT scans, and the metal's always down and the troilite's always up, so you can tell which way it was oriented on the asteroid.
That's awesome.
Okay, so you guys want to see one more?
Yeah.
Yeah, such enthusiasm. Okay, so you can take your gloves off if you want for this one. Unless you're still holding the meteorite, and then you can. Well, you can take your gloves off even if you're holding that thing.
Wasn't there some obnoxious story about the announcement of life on Mars? But maybe it's a.
Oh no, I can't tell them that story.
Sorry.
Okay, so here, I need a volunteer. Did you volunteer the last time?
Yeah.
Okay, here, you can volunteer. Okay, you ready? Okay, I need one finger. Okay? I'm going to put your one finger
This sounds
right
suspicious.
there. Okay? What do you think you're touching?
A meteorite.
Meteorite. Oh, see, in this case, this is a wrong answer. Okay?
Yay!
So I want to give you an idea, because you guys are going to grow up with the idea that microbes and rocks, the Earth, actually interact to form minerals. That microbes are a major driver in geologic processes. That wasn't something that I went through geology with. And you think that's a revolutionary concept, the whole idea of microbes in outer space, microbes on Earth, microbes forming rocks. But you know, we've done this before. So, you want to, do you think it's a piece of wood? I didn't say move your finger. Okay, you think it's a piece of wood?
I don't know, maybe.
Oh, it's not. Well, it's a piece of rock, okay, and it's been impregnated with epoxy like this, okay, and it's a sedimentary rock, right? We all know about sedimentary rocks. You live in Wisconsin, you should know all about sedimentary rocks, okay? Okay. So this is the oldest rock, and this is the youngest rock. So what if I told you you're not touching a piece of rock, you're touching a piece of time? Because each layer records a time, right? So what time do you think you're touching?
An old time.
Oh, that's good. Most people say the middle. So, do you want a hint?
Sure.
Here, there were dinosaurs. Here, there were no dinosaurs.
Okay. So, Mesozoic to Cenozoic then?
You're touching the Cretaceous Tertiary boundary. You're touching the moment, 65 million years ago, that an asteroid slammed into what is now the Yucatan Peninsula of Mexico, creating a hole about 200 kilometers across and throwing up enough dust into the atmosphere to cause the extinction of 70% of all species on life. And that, what you're touching right there, is the iridium-rich layer that was first found in Gubbio, Italy, that is the smoking gun of that impact event. So you're touching the moment that the biological evolution of our planet changed. The Earth didn't change very much. I mean, it was just another blip on the radar of the Earth itself. But to keep in mind, when we landed on the moon in 1969, a lot of reputable scientists didn't think those craters were impact craters. We went from that to the idea there were impact craters on the moon, impact craters on Earth, that impacts formed the moon, that impacts were a major shaper in the history of the Earth, and that ultimately they influenced the biologic evolution of our planet. And we did that all in about 20 years. So 20 years ago, impacts would not have been a big topic of discussion. Sure, there was meteor crater in Arizona, but not much else. Now, meteorite craters are recognized all over the solar system as the fundamental process that has shaped our planet for the last 4 billion years. And in case of asteroids, the only process that shaped them for 4 billion years. This is the proximal ejecta. So this is the stuff that occurs in the Caribbean and in southeastern United States or the southern United States, which is impact spherules. And this is actually the KT boundary. So you can touch this if you want. So there you can actually see the Cretaceous Tertiary boundary.
A local little impact site that's just been discovered at Rock Island, right?
Yeah.
Rock Island.
Back before Dua.
Right near campus. I mean, not far, right? Like half an hour.
Yeah, it doesn't take that long to get over there.
Hey, you want to hold it?
It's about, what, like a couple mile wide over there?
Yeah, we actually have a cubic meter of this stuff. So we dug out. And this is from the Raton Basin in New Mexico. Just don't drop it. It is
Should we hold it over the thing, maybe?
probably wouldn't be a bad idea.
Like holding baby also.
Yeah.
It's a town out.
So, do you guys have any questions about meteorites or anything you'd like to know?
What's in there?
What's in there? These are mostly rare Antarctic meteorites, iron meteorites that tend to rust in the Earth's atmosphere. All meteorites, almost all meteorites, are inherently unstable in the atmosphere of the Earth. So some of the rarest, smallest ones we keep in there. And then we have a more sophisticated facility in Suitland, Maryland, where we keep the cabinets full of dry nitrogen, gaseous nitrogen. And that keeps everything from decomposing. So that's the place we keep, like, we have rocks with salt crystals in them from outer space. So we keep them in there.
Sick.
Anything else? All right, you guys ready to go look at some minerals?
Oh yeah.
Okay.
But I mean, this is really the high point for sure.
Oh yeah.
Yeah.
Can't get past this.
All right.
Thank you, Tim.
Sure.
Thank you very much.
All right, if you guys want to go in front
Should
here,
we keep the one? Do you think Paul will care? Or?
I don't care if you keep them.
I mean,
They'll be
just in
disgusting
case.
in a while.
Yeah, that's true.
So
You're not
you can have like your own bacteriology or.
So are we gonna need gloves over there or no?
You won't need gloves over there now. So
Nice.
and like I said, the gloves are to protect the meteorites from you because the oils in your skin, the oils and salts in your skin will cause the meteorites to rust. So.
Thank you, Tim.
Thank you.
Sure.